Hi and welcome to OpenCV with Python course, a gentle introduction to computer vision. I will be teaching you this course. My name is Morioh. I'm in my senior year pursuing bachelor's degree in electrical engineering at the University of South Florida. I'm a Python developer, passionate about computer vision, machine learning, and signal processing. I love learning and teaching. I currently work as a teacher assistant at the University of South Florida, teaching foundations of engineering. I have been teaching foundations of engineering concepts to freshman students for over a year now, and I have been able to inspire them to continue working hard to pursue their engineering degree. I've learned computer vision while working with my team to create autonomous drone that does aerial image processing. Having learned some of the associated course in signal processing, I have been able to fully understand the computer vision fundamentals. In this course, we'll learn about image fundamentals, which will talk about how to retrieve an image from a working directly onto your screen with Python code. Also, we're going to learn about image processing, image filtering. Furthermore, we're going to discuss topics like feature detection, video analysis, and we're also going to cover some of the applications of computer vision. Thank you for joining this course, and I will see you in the next video. Thank you. We're going to talk about image fundamentals. In my left, we can see an image represented as 28 by 28 array, which also we can see as it looks like number 1. The array has numbers ranging between 0 and 1, 1 being the highest intensity and 0 being white. On my right, we can see that a flower picture. It's an image of 1200 by 1600 pixels, 3 channels, which is red, green, and blue. These channels are represented in decimal, red being from 0 to 255, green also from 0 to 225, and blue from 0 to 255. 000 meaning black, and 255, 255, and 255 meaning white. Anything ranging between that is a variation of these colors. In this video, we're going to install Python 3 and OpenCV 3 in Mac OS X. Firstly, we're going to install Homebrew Package Manager from brew.sh. The site should look like this. Go ahead and copy this link into your terminal and click enter. After that, type in brew update. It will look for updates for the package manager that you just installed, and then here is where we're going to install our OpenCV3. So type in the same terminal brew install OpenCV3 with Python 3, and then the rest of these are dependencies that we'll need throughout our course. Also, when you finish installing everything, it will take about 15 to 12 minutes. Go ahead and type in force OpenCV3. This will link Python 3 with OpenCV3. If you have any questions, I've prepared a tutorial written down that you can be able to go through and see if you have any questions and concerns. But everything that I've said, you should be able to get OpenCV to work nicely. Thank you for watching, and I'll see you in the next video. In this video, we're going to install OpenCV and Python in Windows. So go ahead and download Anaconda and choose either 32 or 64-bit version of Anaconda. Download it and install. After you've finished installing, go ahead and download OpenCV, Python for Windows from opencv.org. Make sure you extract the folder in the C directory. And then we're going to find this file within this directory for 64-bit or this directory for 32-bit. After taking that file, we're going to copy it into our site packages for Anaconda. So the directory is going to look like this. Username should be your name or the name of the computer. We're also going to set environment variable. This should be found in System Properties. Go to Advanced, copy the path and the variable in the respective boxes and click OK. After that, you should be able to start working in Anaconda and launch Python 3 and try to import CV2. If you do not see anything, then go ahead and try to redo the installation. If you have any questions and concerns, please comment below. I'll get back to you as soon as possible. In this video, we're going to write code to read an image from our working directory. The first thing we're going to do is import our packages. We're going to start off with NumPy, and NumPy is going to help us handle the multi-dimensional arrays within the picture. We're also going to import the OpenCV package, which is CV2. The first function is going to read an image from our working directory. The second one is going to help us display the image, and CV2 wait key is going to allow the image to be open for a while until we stop our program, and then last all is going to destroy all the windows associated with the image that we've opened. Let's go ahead and run our code and see what we get. We can see that our image has opened. We can also change the arguments within the function by putting a number, which is, let's say, 0. 0 is going to return an image with a gray color. Let's go ahead and run this. So the image format is going to be in grayscale. We can see it's gray. So if we put a number which is greater than 0, let's say 1, it's going to return the image with full colors, red, green, and blue. Full channels 3, which is red, green, and blue. Let's go ahead and run this. And we see our image has all the colors. Also, when we put a number less than 0, let's say -1, it's also going to read the image as is with the alpha channel. In this video, we're going to write code to read an image from our working directory and also write the image to our working directory in a different format. First off, we're going to start by importing our packages. Secondly, we're going to write a function that's going to read the image from our working directory, which you can see right here. We're also going to write or save the image in a different format, at this point we're going to save it as PNG. The second function is going to show the image that we want to save in a different format. So let's go ahead and run the code and see how it turns out. It should load any minute. We can see the image is saved as PNG. I'm going to walk you through on how to create your own image by using the drawing functions from the OpenCV library. First thing we have to do is we have to define the dimensions of the image. And then creating the image itself, we have to fill numpy arrays with zeros. That will create our black background we see here. And then we're going to use the drawing functions to implement different structures or different shapes within the image. So let's go ahead and take a look at the code and try to implement this by ourselves. In this video, we're going to talk about how to create an image and draw a rectangle within it. So first, we're going to import our packages and then create a multi-dimensional array, and then within that array, we're going to fill it with zeros. We also have to remember to define our image. How big is it going to be? So in this case, my image is going to be 500 by 500 pixels. We're also going to allow 3 channels, which is red, green, and blue, to be represented in the image. Since our image has pixels ranging between 0 and 255, we have to define the data type, which is going to be 8-bit unassigned integer. So let's go ahead and try to view our dark image before we actually draw a rectangle. So we can see here we have our dark image and it has all the channels. Now let's uncomment this line of code and try to draw a rectangle. Now within this code we can see that we have our points to where we want to draw a rectangle. So from 0, 0 coordinates, x and y, to 500 and 150, x and y. And then we have the color. Here I just decided to go with random numbers to get a different kind of color that I've never seen. And then also we're going to define the channels, which is, red, green, and blue. And then the line type. This argument, there's a different type of line, dotted or a straight line. And then shift is going to decide either we're going to minimize the rectangle or leave it as it is. So at this point we're just going to leave it as it is. So let's go ahead and run our program and see how it looks like. Voila, we have our rectangle and it's I think it's green. Yeah, so go ahead and try to create a different kind of color, size of a rectangle, and I'll see you in the next video. In this video, we're going to create an image and we're going to draw a line within that image. So as usual, we're going to import our packages and then we're going to create a multi-dimensional numpy array, and then within that array we're going to fill it with zeros. We're also going to design a 500 by 500 image. We're also going to allow 3 channels, red, green, and blue, and then the data type of those arrays, which is an unassigned 8-bit integer. So we're going to go ahead and write our line function, and then we're going to pass in the multi-dimensional arrays. Then we're going to decide from which point within our image we're going to draw that line to the ending point within that image that our line is going to end. And we're also going to define the color of our line. So let's go ahead and run this code and see what type of line we have. and see we have a red line going towards the end of this image. In this video, we're going to create an image and draw a circle within it. So first we're going to import our packages, and then we're going to create a multi-dimensional NumPy array. We're going to define the size or the dimensions of the image, which in this case is 500 by 500 pixels. We're also going to allow it to have a red, green, and blue, which is the 3 channels, and the data type, which is an 8-bit unassigned integer. And then we're going to go ahead and define the color of our circle, which in this case I decided to go with purple. And then we're going to write our circle function, which will take in the NumPy arrays. And then here we see that it's a coordinate within our image. So in this case, I decided to place this circle in the center. Looking at my dimensions, 500 by 500, I decided to go 250 by 250. So this circle is going to be drawn in the center, and the 50 represents the radius of the circle. So I decided to go with 50, but we're going to change the radius of the circle and see how it changes. But for now, let's go ahead and run our code. So we see that the circle appeared, and yeah, so let's see if we can change the radius of the circle. So let's try to change it to 80 maybe. We see we have a much wider, bigger circle. So go ahead and try to do different colors with the circle, or try to change the radius, or probably create something from the function. I'll see you in the next video. In this video, we're going to create an image and write a text on it. So first we're going to import our packages, NumPy and CV2. And we're also going to create the multi-dimensional NumPy array, and we're going to fill it with zeros. We're also going to create the dimensions of the image, which is 500 by 500 pixels. We're also going to allow it to have 3 channels, which is red, green, and blue. And the data type, of course, which is going to be an 8-bit unassigned integer. Before we actually write our function, we have to define the font, and in this case the font is going to be font hierarchy duplex. The fonts can be found in the OpenCV documentation, and you can try out different types of fonts. So our function is called put text. This is the function which is going to allow us to actually write the text in the image. And we're going to pass in our first argument, which is going to be the picture, the image itself. And here is where you actually write what you want the text to be. So in this case, we wrote Udemy, and these are the coordinates where you want to place the image, the text, and this is the font. This is the size of the overall text, and this is the color. We're going to also define the color, which in this case is white, and the 4 is the thickness of the individual letters within the text, and this is the type of line which the text is going to be drawn with. And the type of line which the text is going to be drawn with also can be found in the OpenCV documentation. You can try different variations of this. So let's go ahead and run our code and see how it looks. So there we go. We see that our text is displayed, and it's Udemy. Thank you for watching. In this video, we're going to create an image Also, we're going to combine every single function that we've learned in the past few videos into one. So in this image, we're going to have a line, a text, a circle, a rectangle, all combined in one image. So let's go ahead and run our image and see what we can achieve. So we see that we have a circle, a rectangle, with the text Udemy, and the line. To be able to place everything strategically like this, like Udemy inside a box with a line underneath, you have to know your coordinates of your image. So for instance, we can see that Udemy is placed within the range of the rectangle between 0 and 500, which in this case is just 100 by x being 100 and y being 100, so that we can get the Udemy name inside the rectangle box. So go ahead and try different variations of this and create your own image. I'll see you in the next video. So taking a look at our translation code, we see that we usually import our supporting packages, which is OpenCV and NumPy, and we also have to retrieve the image that we want to shift either right or left, and then we define the columns and rows. We actually define the dimensions of the image, and then here we create our translation matrix, which is defined as a floating point array. And here we see that we have defined 150, so that means we're going to shift 150 pixels to the right, which is along the x-axis, and we're also going to shift 70 pixels down, which is along the y-axis. And we can see here that we define our shifting function or translation function, which is wrap affine. This takes care of shifting the image. So it takes in the picture argument, the matrix argument, columns and rows, the dimensions of the image. And in this code, we see that we show the shifted image. So let's go ahead and run the code and see what we have shifted, the image, either to right or left. So we see here that the image is shifted to down right. So what if we want to do the opposite of this? What if we want to shift it to left up? The easiest thing to do is you just have to make the opposite of this. This was positive number, so now let's make it negative, and we're also going to make a negative number. So this means it's going to do the opposite of what we did before. So let's see how the picture is going to look like. Here we have the picture shifted to left up. So yeah. In this video, we're going to talk about a subtopic on image processing called rotation. So we're going to rotate an image. So first we're going to import our usual packages. At this time should look very familiar. We're also going to read the image that we want to rotate and also define the image dimensions. And to be able to rotate the image, we have to define the part of the image that we want to rotate. So in this case, we're going to rotate the center of the image. So to get the center of the image, we have to divide the columns and the rows by half so that we get the actual center of the image. And then we also have to define the angle at which we want to rotate the image. And the rotation matrix 2D function is going to create that matrix that is going to be passed on to the function, the wrap affine function, to be able to take care of the rotation. So here we can see that the get rotation matrix 2D takes 3 arguments: the part of the image that we want to rotate, the angle, and the number 1 represents the scale at which we want to rotate. So if we wanted this image to be rotated and scaled, we would pretty much change this to 2 if we want, so the image will be twice as large as before, or we can make the image half as large as it was before. But for this case, we're just going to go with the original size of the image. And as usual, that we use this function on the other video, on the translation video, but now we're also going to use the same function to rotate the image. You might ask yourself, what's the difference between the translation and rotation? The difference here is the matrix that's being passed on to the wrapper find function. Let's go ahead and run the code and see how our image has been rotated. So we see that our image has rotated 90 degrees. And what we can do is, if we want to get the opposite of this rotation, we can just go ahead and change this to minus 90, and we'll pretty much get the same thing but the opposite. So you can go ahead and try different angles: 90, 45, 180, and the image will keep rotating. Hello, in this video we're going to talk about image thresholding. Image thresholding is the binarization of the image, setting an image to either 0 or 1, meaning 0 meaning black and 1 meaning white. So let's go ahead and import our packages. Import NumPy. So let's load our image. But first we have to load the image in grayscale. That's the only way you can categorize pixel value which is less than a certain number to make all pixels 0, and greater than a certain number to make all pixels 1, which is white. So we'll just go ahead and load it, the picture, in grayscale. Also, talking about that certain pixel value number, we have to define it. You might ask, what does it mean? So we have to define a pixel value that if pixels below that range should turn to 0, meaning black, and pixel values greater than this number that we're going to define here right now will turn to white. I'm gonna call it threshold value, threshold. We're gonna set our threshold value to 200. Then we're going to call our function. First, we're going to define the number that's going to be returned, the threshold value that's going to be returned. and we're going to call the function binary threshold. Now we're going to use a function called threshold. We're going to pass our source vector or image that we defined earlier. We're also going to pass our threshold value, and then we're going to pass the maximum, which is meaning 1, right? So 255 is white, so it's 1. And we're going to pass on the type of binarization we're going to do, the type of thresholding, I mean. So in this case, we're going to use a threshold binary. So let's go ahead and try to show our image using the imShow function. We're going to call it binary. And then we're going to pass on our binary threshold function. Then as usual, gonna have to delay it by a couple of seconds to view the image. Then we're also going to destroy all windows. So let's go ahead and run our code and see what we get. So we see some parts of the image is black, some parts of the image is white. So this means that this part of the image, this part of the pixels are less than 200, which means they're going to go to 0 or black. Same applied to this color. We can see, if you can look closely, we can see that the value here is 0, 0, and then 255 meaning 1. We can play around with the threshold value and see how it changes. Let's try 100. Yeah, so you see our image has changed a little bit. So why is this important? I think one of the reasons is to be able to spot different objects in an image in an easier way. You can just define the threshold value and just try to specify a point on image that you want to clearly see. There's another function called inverse binary, which is just going to do the opposite of what we did. So in this case, if we defined our threshold value to be 100, and then below 100 it's going to be 0, meaning black, the inverse of it is going to be white. So the opposite is going to be true. So the opposite is true. Everything that we did is inversed. Thank you for watching. I will see you in the next video. In this video, we're going to talk about a different form of blurring. It's a little bit different from the averaging function that we did on the other video. This blurring is called Gaussian blurring. And let's go ahead and import our packages and write the code to do the blurring. Let's load our image. Let's define our kernel or matrix. I'll just call it a matrix. It's going to be a 7 by 7 ones. Also going to call our function, the Gaussian function, which is CV2 or Gaussian var. There it is. And we're going to pass in our picture, and we're also going to pass in our matrix. And we're also going to have to define something called sigma. Sigma here, it's a standard deviation along the x direction, or the x direction. So in this case, we only want to use the normal Gaussian function and the same size that we define 7 by 7 matrix. If we use the standard deviation, it's going to add more effects to our image. So in this case, we just want to use our Gaussian blur function. So we're just going to write it as 0, meaning it's not going to affect our Gaussian blur function. Now we're going to retrieve and see how our image has been blurred. Call it blur. Also going to pass in blur. Okay. Delay of 0. Let's see how it is. Run. You can actually see the blurring is much more smoother than the averaging, because it includes the neighboring pixels to compute the average. The other blurring function, the averaging, it only took the center pixels to compute the average. But in this case, the Gaussian adds more, they call them weights, to compute the average. Thank you for watching, and I'll see you in the next video. In this video, we're going to take a look at median blur. Let's go ahead and write our code. First, we're going to import our packages. And we're going to load our image. So, what is median blur? Unlike the averaging method that we used earlier, blur, instead of replacing the central pixel with the average neighborhood pixel. In this case, we're going to replace the central pixel with the median of the neighboring pixels. So let's take a look at how this will play out if we write a code and run. The median blur function is used to remove noise from an image. Let's say an image, just think of it literally, taking an image and spraying salt and pepper on top of it. That's noise. The image is not clear enough. So let's write a code and see how this will look like. So it's going to take a number, which is it's going to represent the kernel size. In this case, I'm just going to write maybe 3. So it's a 3 by 3 matrix, and then just going to write a function. Then I'm going to pass matrix kernel. Then going to show I'll call it median. So going to make it delay so that we can view an image, and then going to destroy all windows. But first, let's look at our image and see how it is, so that we can compare before and after applying the median function. Oh, this has to be caps lock. Let's be capital. Let's go ahead and run it again. There we go. So if you take a look closely at this image, you see that it has a little bit of noise. There's little dots. Those are called noise. So let's go ahead and run our function and see how it looks like compared to the one we just saw. There we go. We can see that the dots have disappeared. You can really see them again. Yeah, so this function is really popular for removing the noisy pixels around an image. Thank you, and I'll see you in the next video. In this video, we're going to talk about bilateral filter. In the previous videos, we learned about different functions that made our image much more clear, much more smoother. But sometimes we lose some of the details in the image, like edges. So the bilateral function helps us to preserve those edges. Let's go ahead and write our code and see how we can see how the image has improved after filtering with bilateral functions. Go ahead and load our image. computer.imread. So the bilateral function takes three arguments. The first one is the dimension of the pixel from the center pixel, right? So we're going to create our argument. So this is the diameter from the center of the pixel. So 7 pixels around that area. Then color, I'm going to explain this in a minute. Then space. So the color argument means that we're going to consider more colors near the pixels, and the space argument is going to consider how far from the center pixel we're going to include those pixels in computing our blur function. So let's go ahead and call our function. The name is bilateral filter. And you'll take our source picture and pixel, color, and this how far or the space argument, and then I'm going to show it. Call it filter. Gonna put a wait key. Let's go ahead and run our code and see how it looks like. So when you take a look at our image closely, we can see that it still has some noise, and one of the problems of this function, or the setbacks of this function, is it's not as good as other functions, and it's much more slower. So we can see that in this image, compared to other filtering functions that we've done, it's not performing as well as it should be. Thank you, and I'll see you in the next video. In this video, we're going to talk about feature detection. We're going to use a function called cannyEdgeDetector. Let's go ahead and write our code. I'll explain further when I'm done writing the code. Let's go ahead and load our image. Now, the cannyEdgeDetector accepts 3 arguments. So the first one is going to be a source image, the second one and the third are going to be threshold values. Let's go ahead and define our threshold values. Going to make it a 50. 2. Going to make it 100. Let's call a function. I'll call it Kani. Gonna pass in image. Pass in the threshold values. So the Kani edge detector function is very complicated, but I'll try to explain the simplest way possible. You remember in the earlier videos we learned about binarization? We set a value, then all pixels below or above that value change to 0 or 1, meaning black or white. The same concept applies to the Kani edge function detector. Threshold value 1 indicates that within that range, all values below threshold value 1 are going to be 0, meaning black. And all values above threshold value 2, all pixels above that, they're going to be set to 1, meaning white. This helps us to differentiate between the dark spots and the white spots, meaning the function is going to spot edges around the image, and those edges, they're going to be in white, and the other parts are going to be in black. So creating an image that shows us clearly the edges around the image. Let's go ahead and view our image and see how it is how the edges are shown. I'm gonna call it Kani. So let's go ahead and run our code and see. And there we have it. So we see that the function has been able to spot some of the edges within this image. Let's load our original image and see how well the function has done. In that case, we just change this to pick. You can see that this is the original image. It has tried to somewhat get some edges, but not very well. Let's look at our edges in our picture. There we go. Thank you for watching, and I'll see you in the next video. In this video, we're going to learn how to read or how to stream a video. So let's go ahead and import our packages. Import numpy. Then going to type in a function. The name is going to be called video capture, and inside here we're going to write the name of our video. In this case, my video is called sample video. And we're going to say while cap is open, so if there's a video and it's there, is opened, it's going to return a boolean, which is going to tell us whether or not there is a frame or not. So if there's not, it's not going to give you an error, it's just going to return none. And we're also going to read the video, which is streaming. And then this code might seem very familiar. We're going to use the im show code. We're going to name our video vid, and we're going to pass in frame. Then we're going to break the loop, and this will take care of streaming frame by frame. And then when we press Q, it's going to exit, it's going to quit. Let's go ahead and break the loop. Let's get out of the while loop. Let's release the video or the streaming. Let's destroy all windows. Okay, let's go ahead and run our code. Take a look at our video. Oh, forgot something there. Oh, we have to define exactly what type of video we have, if it's MP4, AV, or any kind. So I forgot to actually name it as MP4. So it should open now. There we have our video. Thanks for watching, and I'll see you in the next video. In this video, we're going to change our sample video MP4 to AVI. In this case, we would want to save or write our video to file. So let's go ahead and define the codec that we want to use to save our video. Notice that we're using the same code, but we're just going to use different function to take care of writing the image to file. Going to use video writer, and going to use the codec name, going to pass in this. This is the 4-character code of the codec used to compress the frames. We're also going to have to define the number of frames per second we want to save in. So in this case, I'm going to save it as 30. I'm going to also define the frame size. You know, when you watch a 1080p or 720 video. Okay, so that's the frame size. So in this case, I'm going to save it as 720 by 480. And then I'm going to output our video. I'm going to save it as out. I'm going to call again our function, video writer. Video. I'm going to save my output video as sample.av. I'm going to pass in the codec. I'm also going to pass in frames per second. I'm also going to pass in the frame size. Let's go ahead and run our code and see. There we go. So because we're using the same code, it's going to play again. But to show you that it has been saved, I can just move this here, and we can see that it has been saved as sample.avi. Thank you for watching, and I'll see you in the next video. In this video, we're going to talk about image face detection. We're going to do face detection on an image using our feature-based cascade classifiers. In this case, we're going to use a pre-trained cascade classifier found in OpenCV. But if we want to build our own classifier, we would have to take a lot of positive and negative images inside our image. Positive meaning there is a face, and negative meaning without a face. And then extract features based on that dataset and train our own classifier. But in this case, we would not. Let's go ahead and write our code. We're going to use our existing face detection code to do a real-time face detection using our webcam. We only have to change a few things. First is going to be loading the image. We're going to change that to the webcam. Going to call our function the video capture function. We're also going to have to return to check if there was frames or video loading or streamed. We're also going to stream the video from the webcam. I think this should be it. I should be able to load our image. Let's also change the name of the text to me. Let's run our code. We can see that it's working perfectly. And we can also see that every time the loop was running, it was trying to find an image to detect a face, and once it has detected, it printed found one face, because it just found one face. Thank you for watching, and I'll see you in the next video. Let's take a look at the face detection code. So first we're going to import our packages, CV2 and NumPy, and also we're going to download the pre-trained classifier to detect a face from this link here. We're going to load the cascade classifier, which is going to take care of deserializing the XML file. We're going to read our image that we want to detect a file on. The scale factor takes care of bringing the image closer to where we want to detect the face. Because different images, the face has different background depth. So some images, the faces will be near the front, and some faces will be too far back end into the background. So the scale factor takes care of it. Also, we're going to load our detecting function. This is going to take care of detecting where the face actually is, and we can see that we've passed the picture that we want to detect the face, the scale factor. And number 5 means the minimum neighbors, meaning the way the classifier works is it detects different rectangles in a face, and that number 5 will determine how many of those rectangles near the face will be included into the region where the face is detected. 4, X, and Y, meaning the dimensions of the image, the width, the height. So we can see here we're going to draw a rectangle within where the face starts and the width. We're also going to define the color of the rectangle that we want to. We want to be drawn around the face and the thickness of the rectangle. Also, we're going to define the font in which we want to write the name Beckham. These functions now should look very similar because we've used them before in earlier videos. We're also going to find the number of faces found in an image, because this is a continuing loop. It's going to keep running, finding faces. So let's say if we had 10,000 faces in an image, we'll be able to count them. And this is going to show the face that we want to, or the image that we want to detect the face. So let's go ahead and run our code and see how the face is detected in an image. Yes, so we can see that the face is detected, and if we scroll up, we can see that it found one face. Thank you for watching, and I'll see you in the next video. We're going to use our existing face detection code to do a real-time face detection using our webcam. We only have to change a few things. First is going to be loading the image. We're going to change that to the webcam. Going to call our function the video capture function. We're also going to have to return to check if there was frames or video loading or streamed. We're also going to stream the video from the webcam. I think this should be it. I should be able to load our image. Let's also change the name of the text to me. Let's run our code. We can see that it's working perfectly. And we can also see that every time the loop was running, it was trying to find an image to detect a face, and once it has detected, it printed found one face because it just found one face. Thank you for watching, and I'll see you in the next video.